Hey everyone, it's Mr. Rosenberg, and for this video we're going to be going over Chapter 8, Section 4, which is special cases of polynomials. So we already talked about, or did multiplying binomials by a binomial, and we went over multiplying a binomial by a trinomial. So now we're going to take a look at some special cases that we have. And that first special case is what we call the square of a binomial. And when we see the square of a binomial, there's some special rules that we can use to simplify it. So first, let's take a look at squares of binomials. All right, they have the form a plus b squared or a minus b squared. All right, see, if you notice, we have a binomial being squared and another binomial being squared, hence the name square of a binomial. So one thing to be sure about is that we cannot distribute this exponent to each term, right? So we can't say that a squared or a plus b squared is equal to a squared plus b squared. This is not true. We can't do that, right? And we'll take a look at how we can square these binomials. But if there's one thing to know, you cannot just square each of these terms since they're being added together. Or same goes for subtraction. You can't just square each of the terms. So now let's take a look. We have this a plus b squared, and we have an example of it down here in the right-hand corner. Right? It says a plus b squared is equal to a squared plus 2ab plus b squared. And let's take a look at why. Right, so we have a plus b squared, that's equal to a plus b times a plus b. And now if we were to go about this using our FOIL method, right, so we would do our first two terms, it's a times a, that's a squared. Our outside terms, a times b, well, that's ab. Our inside two terms, b times a, that's ba. And then our last two terms, b times b, that's b squared. And now if we take a look and we combine our like terms, right, ab and ba, even though they're written in a different order, those are like terms, so we can combine them. Right, so ab plus ba, well, that's just equal to 2ab. Right, and now we can just bring everything else down because they don't have any like terms. And that's how we get that a plus b squared is equal to a plus 2ab plus b squared.